Hi, my name is Gina Porter, and we're going to talk for a few minutes about what third grade math students are doing during the second 9 weeks. Specifically, how they're taking what they've learned about the concept of multiplication and extending it into a little bit larger numbers. So, in the second 9 weeks, they start off talking about the concept of multiplication. Then they relate multiplication to division. And then they take what they've learned and they extend it in so that they can multiply numbers that are a little bit larger. Specifically, they're going to multiply 2-digit numbers times a 1-digit number. This is also part of extending their knowledge about multiplication and division, is using it in relationship to related number pairs. Sometimes we call these in-out tables, or they're basically representing a function. And it represents a real world pattern, and in third grade we put it in a table. They did this also in first and second grade some. The emphasis in third grade, though, is on describing the relationship between the number pairs. So for instance, if I see one cow, I'm going to see 4 feet. If there are 2 cows standing together, I'm going to see 8 feet, and so on. So they need to be able to work with those numbers and to fill in missing numbers on the chart. But more importantly, they need to be able to describe the relationship between the number of cows and the number of feet. So they could say there are 4 times as many feet as there are cows. Or they could describe it by saying, I take the number of cows and I multiply it times 4 to find the number of feet. Or I could take the number of cow feet I see and divide it by 4 to find out the number of cows. So they want to be able to put into words that relationship between the number of cows and the number of feet. Here's another set of related number pairs relating the number of bicycles and the number of wheels. So if we have 2 bicycles, we see 4 bicycle wheels. If we see 4 bicycles, we see 8 bicycle wheels. And so again, we want to be able to describe that relationship. So there are twice as many wheels as there are bicycles. Or I could say the number of bicycles times 2 is equal to the number of wheels. Or the number of wheels divided by 2 tells me the number of bicycles. They need to be able to describe the relationship. Sorry about that. They, as I said earlier, they are also going to start multiplying 2-digit numbers by 1-digit numbers. And so they're going to use all the models that we talked about in the concept of multiplication video, all the arrays, the area model. They can use number lines. They can use repeated addition. They could use skip counting, but usually when we get in numbers this big, they don't. But all the models that were covered in the concept of multiplication video still apply, regardless of the size of the number. When we get into 2-digit numbers times 1-digit number, we start talking about partial products. And as we know, the 2 numbers that we multiply together are called factors, and the answer of a multiplication problem is called the product. And so in this method, we are decomposing or breaking apart the 2-digit number and using it to come up with partial products, which means it's part of the product. And then I can put the parts together and see the whole product. So let's step through this. If I have 37 times 6, I can decompose the 37 and say that it is equivalent to 30 plus 7. And I'm still multiplying it times 6. Now I'm going to say 6 times 7, and I write that down. That's the first step. Then I'm going to multiply 6 times 30. And here's the difference between the traditional algorithm and this partial product method is we are preserving the value of this 3. When we do the traditional algorithm, traditionally people say 6 times 7, put down the 2, carry the 4, forgetting the fact that that's not just a 4, it's 40, or 4 tens. And then they say, and then I multiply 6 times 3. Well, we're not multiplying just 6 times 3. We're multiplying 6 times 30, or 6 times 3 groups of tens. and then we have to add in these 4 extra 10s. So when we use this method, we're preserving that place value. So let's get back to our process. Sorry, I digressed. We're going to multiply 6 times 7, and we're going to write down here that we're going to multiply 6 times 7. We're going to make 6 groups of 7. Then we're going to multiply 6 times 30, or make 6 groups of 30. And we write that down here. Then we carry out the multiplication. 6 times 7, or 6 groups of 7, is 42. And 6 groups of 30, or 6 times 30, is 180. So this is a partial product. It's part of the product. 180 is another partial product, part of the product. And then I take these two parts and I combine them, I add them, and then I get 222, which is the actual product. So we call this method the partial product just because we find parts of the product and then we combine them to find the whole product. And they'll continue to use this method throughout 3rd grade, and next year when they start multiplying 2-digit numbers times 2-digit numbers, they'll also experiment with this partial product method again. There are other strategies that they could use. They're number sense strategies to help them multiply. 48 times 3. I am looking for 48 groups of 3. Well, I know that 48 is only 2 away from 50. So if I add 2 more groups of 3, I can find 50 groups of 3. And 50 groups of 3 is 150. 50 is an easy number to multiply times 3. But I added 2 extra groups to make it easy on me. So now I need to take those 2 extra groups of 3 away. And 2 groups of 3 is 6. So I have to take 6, or those 2 extra groups of 3, away from the 150. And 150 minus 6 is 144. So for some kids, it's very natural to think about number relationships like this, and to do a lot of mental math to multiply even large numbers. They're also going to talk about the fact that we can have multiplicative comparisons. That we can know that 3 times 24 represents 3 times as much as 24. And here are a couple of example problems. Yuri had 24 stickers in his collection last week. He got a lot of stickers for his birthday, and this week he has 3 times as many stickers as he had last week. How many stickers does Yuri have now? So now he has 3 times as much as 24, or 3 times 24. Another example, Evan is 8 years old. His cousin Sylvia is 4 times older than Evan. How old is Sylvia? I see a couple of typos on this page. I apologize. But we know that if we take Evan's age and multiply it times 4, that would tell us Sylvia's age. Again, this is how they're going to extend their knowledge and use of multiplication. And if you have any questions about this topic or any other 3rd grade math topic, feel free to contact me via email at jporter@csisd.org, or you can call the school and leave a message and I'll return your call. So again, thanks for listening, and in January, on January 5th, we will have another Math for Parents session to cover the topics that your students will learn in the 3rd 9 weeks. So again, thanks for listening and have a great day.